Um, I also have to drop off at past, so I'm glad that somebody
Yeah,
else.
you don't want to record because you lose the recordings.
Oh, that too. But I also have to drop off at past this time.
Oh, Jakob, you got the first one.
Yeah. There's this. Yeah, it's something that has been on my mind for a while, and I had a bit of downtime, and I thought I'm just going to see if I can get this working, and it looks like it works. So this started when a while ago, Matt and Igor did an investigation into CPU spikes on one Gitly server, where they noticed that sometimes it's at 100% CPU, and that a lot of it is because of system calls in Gitly and in Git, because it's all about the find all tags RPC in that case. So there's a repo with a lot of tags, and something is fetching those tags in a loop. And it turns out that Gitly implements this type of RPC where it has to yield many objects in a very inefficient way. So when I saw that issue, I started paying a little bit more attention to this, and I noticed a second problem, which is not just about the I/O, but also about the memory allocation. So I started thinking, is there a way to do this better? And actually, 1 or 2 months ago, somebody also asked me if somebody from the Gitly team asked me if I had any ideas of how to make final tags more efficient, because it was something that kept coming up. So I've been working around with this idea, and now I finally thought, let's put something together. And it turns out that we can do better. So I made a benchmark where I took the GitLab or GitLab, like a local clone in GDK, and in a Rails runner, I built an array with all the tags, which is what the client side of find all tags looks like. And then my benchmark was to do that 100 times in a row and see how fast it goes. And with the status quo, that was taking 59 seconds for 100 calls, where we built an array of all the tags in GitLab or GitLab.
And that's the measurement on the Ruby side?
On the Ruby side.
After they're turned into tags and like.
Yeah. Yeah, so the time it takes to build an array of GitLab git tag Ruby objects. Well, I can actually just show you what the benchmark is. So the benchmark finds project 23. It takes the role repository, so there's no caching. And then it says repository.tags 100 times. So that makes, yeah. So it's kind of, I think it's a reasonably end-to-end benchmark, but it doesn't include the overhead of, if you would make API calls, you also have JSON serialization on top of that. So with the branch I'm testing, or with the version of GitLab I'm testing on, it takes 59 seconds to do that 100 times. And then I started to make an improved version, and I could get that down to 9 seconds for 100 calls. So that's nice, because that means it goes, so this is single threaded in a loop, and it means that goes 6 times faster. And I also took flame graphs. So after I did that, so the benchmark is just 100 calls. And then I turned on another script where I do the same thing, but with an infinite loop. So then you enter a steady state of single threaded traffic. And then I run a 30-second profile to see what the server is doing. And in those profiles, you see, so this is one from the status quo, I think. You see, yeah, it's probably interesting to look at the status of that for a moment. So in the status quo, Ruby is actually not doing a lot of work, but Gitly is doing a lot of work. Git is doing a lot of work, and prefect is barely visible. But the thing I was focusing on was the Git and the Gitly part, because that runs on the Gitly server, and that is not horizontally scalable. Prefect is, and prefect is also not the biggest part of the pie here. So in my table, I summed the number of samples for these two things. And there, so the status code was in 30 seconds, 4,500 samples, either Git or Gitly was doing stuff on the CPU. And when I put this improved version or this alternative implementation in steady state, and I take a 30-second sample, then Git and Gitly are together 3,300 samples on the CPU. But if you take into consideration that it's doing more calls, that means it is 10 samples per call instead of 89 samples per call. So that means 9% less CPU workload. I think that means 9%, 9 times less CPU workload. So from 89 to 10 on the GitLab server.
Jakob, sorry I arrived late, so you've probably answered this, but is find all tags implemented as a server stream?
Yes.
And does each tag come back as a separate message?
No.
Okay, so it's batching them.
It's batching. Yeah.
And how big are the batches?
Fairly big.
Like 5 or 100 or bigger than that?
Closer to 100.
Okay.
I think in the original.
Wow, and it's still. Yeah.
Yes, in the original implementation, the batches were like 10 or 20, and then somewhere along the line, John Kai wrote some smart code where he calculates the size of each protobuf message, and he packs as many into a fixed window as possible. And I don't remember what the fixed window is.
Okay, so it's right. So it's a smart. That's even.
It is already batching them.
Yeah. Okay. That I was just wondering whether just batching would give you much of the same effect, but that's amazing that it gives you that much over batched gRPCs.
Well, the funny thing is that in the status quo, you can actually see that Prefect is doing very little. And that is, I think, because the batching is working well. Prefect has to copy very few gRPC messages. And if I look at the improved version and its profile, then Prefect has more work to do and GitLab has more work to do. And Git is more active here. But again, this is when it's doing 6 times as many requests. So it has an excuse to use more CPU.
It's doing more work.
Yeah,
Working efficiently, not what is the thing? Not hard.
And it could even be made more efficient because, well, you can't see anything here, but I know that Git is using a 4 kilobyte buffer on its end. And in other scenarios, I tried, Git currently doesn't let you make that buffer bigger, but if you do, you also reduce syscalls. So I think we can probably reduce this Git block if we can get Git to use a bigger standard output buffer. But that's an aside.
So.
But it's a really go ahead. I want to say something about how it's done, what the magic is, or well, what's different. But you have go ahead.
Well, the sort of where the trend that I see here is that we are taking all the gRPCs and the ones that are the most heavy and the most expensive from a gRPC point of view, perhaps, and turning them into binary streams of a sort. And obviously we can kind of do this one by one. Is there like an alternative that is something like gRPC, but is like a lot more efficient, where we can get the benefits of because obviously gRPC has huge benefits in terms of like, you know, understanding the structure of the data coming to you and repeatability. You know what I'm talking about, but obviously it's got a massive downside as well. But it's kind of like we could say we can turn everything into assembly and it'll be much faster, but there would be a big downside to that as well. Is there like, it's a lot of work and not very maintainable.
It's a good question. There's actually 2 different patterns going on here, because I think you're referring to the Git fetch efficiency epic we're working on, which is also about byte streams. In that case, we're taking RPCs that already are byte streams. They're just byte streams encapsulated in gRPC messages. And if you're transferring gigabytes of data, that is
it doesn't make any sense. In that case, it definitely makes sense just to leave it as a byte stream. There's no question about it.
So there we're saying we're going from a byte stream encapsulated in gRPC to a byte stream in YAMX, and we expect that to be much better by the time we're done. In this thing, we're still using a byte stream encapsulated in gRPC. So we could get the improvement from the other thing on top of this if we really wanted to, except YAMX is a Go library and there's only a Go implementation. So we can't really use the stuff we're building for the Git fetch efficiency project for this, unless we re-implement Yamux, which was, yeah. But of course, if we had something that was not gRPC and that was primarily oriented towards byte streams, then both of these things would work well. But just by putting a byte stream on encapsulated in gRPC messages, we're able to get this improvement. And one of the reasons is
how are you delimiting the, like, is there a 0 between each item in the byte stream, or how are you how are you structuring that byte stream?
Yeah. There's a Git command called catfile, and that has a batch mode where you give it a bunch of object names on standard input, 1 per line, and then it dumps them out on standard output. And that is the format. So that has a header line that you can parse. So you just read until a new line and you break it on the spaces, and then you know next, and then that header line.
That's why grit is back in those commits you linked.
Well, I actually took grit out again because I could go faster without it. But so the format
what is grit?
Grit is a gem that GitLab used to use to parse data that came out of Git. Something we used before Rugged existed. So for old timers, it's very much a throwback. So the format of the stream is the more or less the output format of Git catfile batch, and that format is easy to parse. It is one header line, like I said, one header line followed by a new line. So you can read that with buffered.io, and then you have a length prefix, so you know that the next X bytes are the raw binary representation of the Git object. And then there is another header line, or there is end of file. So that is easy to parse, and then you need to parse the binary format of Git objects, but it's basically a text format that you can parse with awk. It's a very friendly to parse. It's not a difficult format to parse. But that is actually one of the disadvantages that are listed here, which is that for this to work, the client side needs to have this parser for the Git object format. And currently, Gitly has a parser for that, which we had to build there. And I hacked one together that works well enough, but I didn't write a test suite, so I'm sure it has bugs.
it kind of moves Gitly back into more of a proxy, like a Git proxy, even more than it was, right? Because it's kind of like,
and I think that, and this is a bit of a crazy idea, because we made this design choice early on that we parse on the Gitly server and we return structured objects, and we use protobuf for the structure because, well, we have protobuf, it's gRPC, that's what you do in gRPC. But all that parsing happens on a non-scalable resource, and it can just happen just as well on the client. And the other problem is that because of the parsing, parsing is just an intensive CPU-intensive job. And what's happening now is that Gitly reads the Git object format, it parses that into a Go object, so that's one time of parsing. Then it serializes that into the protobuf wire format. So then we're back to bytes. Then gRPC sends the bytes across the wire, and then the bytes come out in Ruby. Then Ruby takes the bytes and turns them into a Ruby protobuf object. And then we stick that Ruby protobuf object into a wrapper class in Git, and then we use it. So there's
why was that design choice made in the beginning?
I'd say it's a sound design choice. Like you want to encapsulate your because that means you can replace the back end of Git with other implementations.
With, for example, Gitly, because I think GitLab Git commit thing stems from before Gitly.
No, but the question of why the commits structured, I think it's just a natural design. I think it's the most obvious design. Like if you look at an API, a JSON API for getting commits out of GitLab, then you don't get one big blob in the native Git object format. You get a structured JSON object that is easy to get fields out of. It's just easier to consume for a structured object is easier for developers to consume.
If you look at any other,
So it's a case that it was a reasonable design choice at the beginning. It's just that it's gotten to the point that we can't, from a scaling perspective, it's just not the best choice anymore.
Yeah, it's with what I know now, I would say it is not the most efficient choice, and um, it's it forces you down a path. And Andrew asked about batching. So we create these Go objects, one per commit, and then we batch them before we send them out. But that means that we need to allocate memory for each of these objects. Well, in order to parse these objects, we need to keep allocating new buffers, and we can't reuse them until the whole batch goes out. So with a batching interface, it's harder to reuse memory. And you need to worry about where the boundary is. And if you're just copying bytes, then you don't care where the boundary is. You just say a byte, the boundary can be at any byte. You send out the message, you go to the next one. So it adds all this complication to Gitly, and with where we are now, it added up to make things slow.
It kind of reminds me a little bit of like, I'm going to date myself here, but like when people were building like XML services, and it was very similar. You would have a service, and it would you would have a DOM, and you would build up your objects, and you'd generate your stubs and everything like that. And it was basically just gRPC before gRPC, right? And then you'd populate it, and then at some point the service would be scaling up, and you would have a big problem with the performance of the server. And then at that point, the nice thing that you had in the RPC times was that you could replace it so that you weren't doing that part of creating an object and arrays of objects and then populating it and then passing it to the parser. You would just switch over to a JAX emitter, right? Where you would just basically send it events, and it would stream those down, and then you'd get like a 100x speed up, which is exactly what you're doing here. But the nice thing is that the client side would kind of be the same, because the client didn't have to, you could kind of independently change those two sides. And then the client could actually switch over to a JAX parser as well. And then you get the speed up on both sides.
It's not exactly the same problem, because with the stream parser, the problem is that you don't want to build this huge intermediate state when you can do the job in a stream.
Yeah, but that's what the JAX, what JAX was, right?
Yeah, but it still means you're parsing XML. It just happens that you can.
Yeah, you're not putting it into an intermediate form.
Yeah, there's different approaches to doing that, and it's harder to program because you need to program callbacks, but you go much faster. But the difference here is just not parsing at all. It's as if, imagine you had a log full of JSON lines, and you wanted to send that somewhere else, and you parse each JSON line into an object in your programming language, and you dump it back to JSON before you write it into a socket. It's faster if you never parse it in the first place and just write it into the sockets.
Yeah. I still think that there is a benefit overall to having an abstraction. Like say you wanted to change Git for, I don't know, something. It's a sound abstraction to have. And if you look at every other gRPC service, we're not just sending back raw files. It's the same. We use that same way, because it's a sound way of building things. It allows you to change your server without always impacting your client, and that's a good thing, like architecturally. But I think in this case, the benefit is there, and the advantage, and we get value from kind of dropping that abstraction. But I don't think it's like automatic that you should drop it. But in this case,
no, like I say, it is the natural design choice to do what we did.
Yeah.
But for the sake of efficiency, it's just not always ideal. And
especially find all tags is one of those terrible endpoints. That's just always the problem.
Yeah, but it applies to. Sorry, go ahead.
Is this thing that we're like, what's causing it to be so much slower? Is it the deserializing, or like the parsing on the Gitly side, or the putting it over the wire in the gRPC messages?
I think the unbuffered IO is the biggest problem. So that means that you have one Git process that is creating a list of all the tags, and what Gitly does now is it reads one item off the list. So that's a system call, and then it writes it into another process, and then that returns the tag, and then it Gitly reads it back. So that's 2 more system calls, and then it parses that and it puts it in a gRPC message and throws it on the batch. So you have
Another, yeah, go ahead.
and the difference is that now we have the Git process that it generates the list. It talks directly to the via a pipe into the Git process that fetches the objects. So it writes still 1 line at a time, but they come out as 4 kilobyte chunks. So it only does a write every 4 kilobytes. And then the process that generates the objects also does that. So there's way fewer system calls in that chain. And then Gitly only gets woken up when there's 4 kilobytes of raw data, and it needs to send that over the wire. So everybody spends more time in user space and less time making system calls.
Another, and this does, like, I think this is not going to change the fact that this work should get done, but like, I think some of the problem is that find all tags should almost never be called, because there are lots and more all the time repositories with 20, 30,000 tags on them, right? And people use find all tags because we also have problems with find all tags in Redis and the cache that we have and the amount of data that we transfer in and out of that cache. And what it is somebody needs to display a page, and it's got a list of tags on the page, and they do find all tags. And, you know, in their mind, they're thinking that there's going to be 10 tags on the repository, but there's 30,000 tags, and it's putting pressure on Redis. It's putting pressure on, obviously on Gitly. It's expensive for the application. You use lots of memory. And most of those cases, like a user can't, you know, if it's obviously there are merge requests and sidekick jobs and stuff that might need all 30,000, but most of the time a user doesn't need to see 30,000, you know, so it's almost like they shouldn't be, they can't see it. There shouldn't be a way to call that endpoint from the web, because it means that something's gone horribly wrong in the architecture or the design of a controller. But it is used all over the show, and it causes us a lot of problems.
I think that the reason that it's used like this is because there's no nobody has built something like a paginator for tags yet.
Yeah,
but they built the paginator for branches already, and I don't see why it wouldn't work for tags.
Yeah, I just recently reviewed something that was unrelated to this, but I was also listing tags and then just taking the first, I don't know, handful of them. So if you do that for a repository with loads of tags, that's a lot of work that GitLab server is doing to throw away on the other side.
Yeah,
and it's Redis as well. You know, there's so many things that, you know, because we had that ZSet implementation that checks existence of tags and everything, and there's so many things that are really expensive because people assume that there's like 10 tags on a repository, and it's only going to get worse as time goes on, right? People never delete tags.
Yeah, this has been broken forever. So it can and should also be improved on the client side.
The thing that I was reviewing on the client side was high deadline exceeded errors for final tags, basically.
Yeah, well, thanks anyway for listening to this. I'm not really sure what to do with it because we have lots of other projects going on, and it's also quite a radical departure of how the rest of Gitly works. So I'm not sure if it would be easy to sell this to the Gitly team, or where this even fits into our other priorities. But I wanted to see if it worked, and so I now can happily say that yes, it works.
It might be that this is one of the things that we keep in the back of our mind for when we start to have problems in this area. We know that this is something that we can do to alleviate it. Because I think with all of the other things going on, I agree with you. I'm not quite sure how we would get this prioritized to do unless it was very, very clear, we have to do this or that's going to explode.
Well, one practical thing I can say is that Matt created an InfoDev issue about these final tag problems. So we could take this as a possible solution to resolve that infra-dev issue, but that doesn't tell us who's going to do it and when.
Wouldn't the whole pagination thing and so on be more like a better thing to work on than this? Because most of the time, like even now, you found a very efficient way to push all those tags into Ruby, which is awesome. But do we need that?
We shouldn't. We should. It would be better if we didn't have all those tags in the first place.
And
like
that made me
90% of
wonder
the
how
time.
many of these all methods do we have that load way too much from Gitly? I have no idea if
There's
maybe
find all branches and find all tags. Is it branches or refs? Whatever. But
We have a couple of them.
yeah. Just one other thing, Jakob, do you think like if you implemented that, like maybe the way to kind of approach it is to say what we do is we kind of closely couple the Gitly client and the Gitly server, or we make them more coupled. And so that implementation detail change is kind of in the, Gitly client being the Ruby class called Gitly client or whatever that's become since I last looked at it a long time ago. But basically, like when you do the find all tags, from the caller's point of view, the abstraction remains the same. It basically gives you an array. But and then you don't have to kind of push that complexity of this new abstraction and parsing onto like front-end developers. Yeah. Okay.
The proof of concept stuffs everything in Gitly client. I just opened the file.
Okay. Then that's a lot better. Then I think the cell is a much easier then as well, because you're not pushing it onto like everyone in the organization.
No. So you don't. It's almost all hidden in Gitly client right now, and that not in a completely natural way, but that's where the response stream comes in, and and an array of GitLab git tag objects comes out.
Yeah, in that case, it's probably something you could sell fairly, like relatively easily. But yeah, when?
No, I think part of the sell is first towards Rachel and the amount of time it costs, and I don't know how people how a wider audience would feel about this concept of not emitting structured data or emitting data in a custom as a byte stream like this. But anyway, I just wanted to, like I said, I wanted to share it, and I think we have enough other things going on before this before we'd have time for this.
No, thanks for taking us through that. It's I was quite surprised by the difference in the result, so it was good to see.
One of the weird things, by the way, was that just one more thing, but I started building this, and at first it was twice as fast, and I thought, wow, this is amazing. And then I started fiddling with the Ruby code, and then it went, I got it 3 times faster after that, and then I ended up at 6 times. So that was a bit crazy, but that's how much how much different that made too.
Jakob, like if you move this over into GitLab or GitLab, this issue, and related it with all of the find all tag alerts that we've had over the last, I mean, we could get the Gitly team to do this, basically.
I think they have some other stuff on their mind, but
I'm just putting it out there that we can probably get, you know, because it's if you're worried about like
it might make sense to move it over to GitLab or GitLab, because that's where the infra-dev issue lives.
Is there an infra-dev issue? Okay.
Yeah, I have to drop off. Sorry about that.
Cool.
But thanks for listening, everyone, and for the conversation.
Yeah, I'm going to need to drop off as well, unfortunately. Thanks so much for recording this, Bob.
You're very welcome. Andrew, do you still have something to show me?
No,